Good morning, students. In the last lecture, we discussed about the superposition of waves and the analytical treatment of the superposition of waves. We also derive a relation for the displacement of particles of a medium when two waves superimpose at that point simultaneously. We also derive a relation for the resultant amplitude of the two superimposing waves. Today, we are going to discuss the applications of this superposition of wave, and the first application and very important application is stationary waves. How stationary waves form? For the stationary wave, what is the definition of stationary waves and what are the conditions for the stationary waves? We are going to see in this lecture all about the stationary waves. First of all, we see what do we mean by stationary wave. As the name implies, stationary. Stationary means at a particular point it remains at that place. Okay, so the wave which remain in a localized condition, which remain in a particular area, is binded in the particular area, such type of wave is called as a stationary wave. We know that wave is nothing but the mode of transfer of energy from one place to another place, but stationary wave indicate the wave but which is localized in a particular area, which is bounded by the particular region. So in this way, stationary wave are the wave which are bounded by the rigid supports and there is no transfer of energy as they are stationary or they are localized in a particular region. Okay, now how these stationary waves are formed? Stationary waves are formed when two waves having same amplitude and frequency. When two waves having same amplitude and frequency superimpose on each other, mix with each other, combine with each other, then they form a wave which is called as a stationary wave. But what about the direction of these two waves? The most important condition to form the stationary wave is that these two waves must have opposite direction. They traveling along the same path. They traveling along the same path, but they are in the opposite direction. And when they mix with each other, they arrive at a point simultaneously. They produce a stationary wave. So, how we can define a stationary wave? The stationary wave can be defined as when two waves having same amplitude and same frequency superimpose on each other and traveling along the same path but in the opposite direction, they form a stationary wave. Or it is also called as a standing wave because there is no transfer of energy in the stationary waves. Okay, this is all about the definition of the stationary waves. How stationary waves practically form, we are going to see here. Consider that these are two rigid supports and between these supports a string is fixed. A string is fixed between the two rigid supports. When we pluck the middle of the string, the waves are formed and traveling in the opposite direction. A wave is traveling in this direction, similarly another wave is traveling in this direction, and when these two waves collide with the rigid support, when these two waves collide with the rigid support, the incident wave and the reflected wave combine with each other to form a stationary wave. What is the structure of the stationary wave? We can imagine like this. So, in this way, the stationary waves are called. Suppose this arrow indicates the incident wave and this arrow indicates the reflected wave. Then, due to the combination of incident and reflected wave, a stationary wave is formed between the two rigid supports. Now, in the case of stationary waves, as we consider, transverse wave is made up of crest and trough, longitudinal wave is made up of compression and rarefaction. In the similar way, stationary wave form of or stationary wave consists of two parts, node and antinodes. There are 2 points in the stationary wave which are going to explain here. So what is node? Node is a point which which vibrate with the minimum amplitude. Now, particle of this rigid support, particle of here, this particle, these particles vibrate with the minimum amplitude. Such points having minimum amplitude are known as the nodes. They are known as nodes. And the particles which vibrate with the maximum amplitude, the particles which are vibrate with the maximum amplitude, such points are called as the antinodes. So, stationary wave consists of 2 points. Some points vibrate with the minimum amplitude, or we can say that they are at the rest position, and another points which are vibrate with the maximum amplitude, they are called as the antinode. Therefore, stationary wave consists of node and antinode, and we can say that this node and antinode are alternately formed. Means, suppose here is a node, then there is an antinode. After antinode, there is a node. So we can say that this node and antinode are alternately produced in the stationary waves. Now we are going to discuss the formation of the stationary waves. How stationary waves form? By analytical method. What is analytical method? Analytically means by using the equation we can derive a simple relation, or we derive the relation for the stationary waves. Why it is called a stationary wave? We get the answer of this question after this equation. So, while considering the analytical treatment of the stationary wave, we need two waves having same amplitude, same frequency, but they traveling in an opposite direction. So, here we are going to consider such two waves having same frequency and amplitude, but they are traveling in the opposite direction. And we know that while performing or while superposition of wave, the particle performs simple harmonic motion. So we are considering here the equation for the simple harmonic motion as well. So what is the equation? The equation is that this y1 is equal to, what is the equation? This y1 is equal to a sine 2 pi nt minus x by lambda. This is the equation of a progressive wave which is traveling in the positive direction of x-axis. Okay, so we can say that this is a single wave which is traveling along the positive direction of x-axis. Now we need to consider another equation, another wave which is traveling in the negative direction of x-axis. So what is the equation for that? The equation is y2 is equal to a sine 2 pi this nt plus x by lambda. Remember the equations, these relations are very simple, but if the wave is traveling along the positive direction of x-axis, then we need to put here a negative sign. And if this wave is traveling in the negative direction of x-axis, we need to put a positive sign. So these are the two waves which are traveling along the positive and negative direction of x-axis. Consider these two waves superimposed at a point, at a particle of medium. Then what happens? What is the resultant amplitude? We know that according to the superposition principle, the resultant amplitude is the vector sum of the displacement due to the individual waves. So we can write here y is equal to y1 plus y2. So we can write here is a sine 2 pi nt minus x by lambda plus a sine 2 pi nt plus x by lambda. These are the two waves. Now here this a and this is common, so we take out the common a and write here sine 2 pi nt minus x by lambda plus sine 2 pi nt plus x by lambda. Now this can be solved with the help of a trigonometric relation which state that sine a plus sine b, sine a plus sine b, which is equal to 2 sine a plus b divided by 2 into cos a minus b divided by 2. This is the simple trigonometric identity. By using this identity, we can solve this equation. Here, this whole is considered as A and this whole is considered as B. So we can, first of all, we calculate this A plus B by 2. So what is A? This A is 2 pi, which is common in the both angles 2 pi. Here we write nt minus x by lambda plus nt plus x by lambda, and this is divided by 2. So here this plus x by lambda minus x by lambda both are cancelled, and we can write here this 2 pi twice nt divided by 2, which is equal to this 2 to get cancelled, so we can write here this 2 pi nt. So what is the value of a plus b by 2? It is equal to 2 pi nt. So we can write here this a into 2 sine, what is this? It is equal to 2 pi n2 t. Okay. Now plus, or we can multiply this equation, is cos a minus b by 2. Now what is a minus b by 2? This 2 pi is common. It is nt minus x by lambda minus nt minus x by 2, and it is divided by 2. This plus nt minus nt get cancel. Minus x by lambda, it is minus 2x by lambda, minus 2x by lambda divided by 2. What happens? Minus x divided by 2 is equal to, we can write here, this minus 2x by lambda, and this is 2. This 2 to get cancelled. Therefore, we remain here, it is 2 pi x by lambda. This is the negative sign, and cosine of the negative angle is equal to the cos theta. So we can write here is cos 2 pi x by. Now this equation can be written as twice a cos 2 pi x by lambda into sin 2 pi and t. Now we substitute this value, so we can write here this y is equal to, we substitute this value as a, so we can write here as a sin 2 pi and t, but we know that this 2 pi and 2 pi n is nothing but omega, so this is y is equal to a sin omega. So this is the equation for the stationary wave form. This is the analytical treatment. By using the two equations we derive this equation. Now from this equation we can conclude that the combination of two waves having same frequency and same amplitude, when superimposed with each other, they form another wave in which there is no term of the displacement. This is the equation of the progressive wave. Why it is called as a progressive wave? Because this contains the displacement and time. As the time changes, the displacement of the particle also changes. But in this case, there is no term of the displacement, and if the displacement term is absent from this equation, so we can say that this wave is not traveling from one point to another point, but this wave is remained inside the or within the bounded, within the rigid supports. So in this way, how the stationary waves are formed? By the analytical treatment, we can prove this analytical treatment like this. We need to show that y is equal to a sin omega t, and we also need to state that the term of x, that is term of the displacement in this equation, is absent. Therefore, this equation represents the stationary wave. Okay, so when a wave is localized or it is bounded between the two rigid supports, it forms a stationary wave. And what are the important conditions to form the stationary wave? The important conditions are that these two waves must have same frequency, same amplitude, traveling along the same path but in the opposite direction. So in this way, today we discuss the stationary wave, what are stationary wave and how they form, and the analytical treatment of the stationary waves. In the next lecture, we are going to discuss the conditions for the formation of node and antinode as well as the properties of the stationary waves. So today we are going to stop here. In the next lecture we are going to discuss another very important properties of the stationary waves under the chapter superposition of waves. Have a good day. Bye.